All right, so this lesson is on section 5.4, and it talks about transformations of both exponential and logarithmic functions. This will be the 5th time that we have talked about transformations in Algebra 2. So we did it in Chapter 1 with linear and absolute value. We did it in Chapter 2 with quadratics. Chapter 3 was cubic functions. And Chapter 4... square roots and cube roots, and then now we've got exponential and logarithmic. Here's the good news. They are all going to be the same. They're all going to be the same. So if you remember the transfer, like moving it up and down and left and right, all of those rules, they are the same. And actually, in some cases, they're a lot more obvious. So if you just take a little look here, let's remind ourselves, if you want to move left or right, they call that a horizontal translation. Take your little highlighter there. See how it's got the x minus 3, and it's with the x. So if it's exponential, the minus 3 is going to be part of the exponent. That's going to move it right 3. And then if you add 2 to the exponent, that's going to move it left 2. So remember, whenever you add and subtract to your x, it's the opposite of what you expect it to do. So it's going to, so if you add, it's going to go to the left, and if you subtract, it's going to go to the right. So it's really, look at the difference. I feel like it's pretty obvious that you've got this really big, like +5. So it's not part of the exponent. So you know it's being added to the function. So when you're adding to the function, it's going up. And if you're taking away from the function, it's going down a unit. So let's talk about reflection. So there's 2 different kinds of reflections. You have a reflection over your x-axis, and then you have a reflection over your y. So a reflection in your x-axis is going to be in the front. It's going to be in the front of the function because you're multiplying the entire function by -1. If it's over the y-axis, it's going to be with the x. Now these are all exponents. So on the first half of your notes, these are all exponents, and on the back half, it's logarithms, okay? So this next one, we're not really going to talk about horizontal stretch or shrinks in this lesson. I know we've talked about it before, but for now we're going to skip it. And then vertical stretch or shrink, let's say you got a 3 in the front, so that means that you're multiplying your function by 3. What it's going to do is it's going to pull that function away. It's going to stretch the function away from your x-axis. That's why it has that like rubber band, like stretchy effect to it. Because you're multiplying your y coordinates by 3, and it's making them bigger, which pulls it away from your x-axis. This one, on the other hand, is 1/4. 1/4 is going to have the opposite effect. What it's going to do is it's going to squish it toward, so it's going to compress it or shrink it toward the x-axis, because all of your y values are getting smaller because you're multiplying it by a number between 0 and 1. So just keep a lookout for all of those things, and let's do a little bit of practice. So here's what you want to do. There's not really a parent graph to like an exponential function. So you need to see if there's any differences, like any changes between the f function and the g function. So it has the same base of 1/2. We know it's a decay, but the only thing that's changed is this part right here. So I would just suggest highlight that on your paper so you know. And if it says -4, you're subtracting from the function, not the x. Okay, so what's happened is I'm subtracting 4 from the function and not the x. So that means I'm going to move this thing down 4 units. All right, next. It's all about location. So what do you see here? I'm seeing 2 things, right? I'm seeing that there's a +5, and I'm seeing that there's a -2. So what do you think that would be? What about that -2? That's going to move it to the right 2 because you're subtracting from the x. And then this +5 is going to make it go up 5. Okay, so since we've done this 5 times already, or the 5th time now, I want you to try these 3. So pause the video, and I want you to write down or highlight, and then write down exactly what's happening in each of those 3 examples right there. All right, let's see if we got it right. So I highlighted the change between the f and the g function, and it was the -2 from the x. which is going to make it go to the right 2. Okay, and this is the second one. We had 2 changes here. So that's going to go to the left 1, and then it's going to go down 6. And the last one, we have 2 changes in this one as well. We're going to go to the right 3, and then we're going to go up 1. So this is like a little separate section right here, but honestly, it's the same. Okay, do you see? It's the same. Instead of having like a number base, it has base E. Okay, so what do you think is going to go here? That's +3 on the x, and then that's +2 on the function. So that's going to move it to the left 3. And then everybody all together, what's that one going to do? It's going to go up 2. Good. Okay. Same thing over here. We've got a translation to the right 4 and up 1. So right 4, up 1. So we've had a lot of practice with translating up, down, left, and right. All right, flip it over on the back. We're going to start talking a little bit more about reflections and vertical stretches and strengths on the back. So this is logarithms, and it's got examples, but there is one major difference between this one and on the back. Now, on the back, it didn't use parentheses. Because when you write something as an exponent, like it's obviously written with an exponent. But if you look on the logarithm, if you're going to add or subtracting to the x, you're going to have to put parentheses around it. So there's going to be a very big difference between log of like 20 or log of 20 plus 2. This means, okay, let me show you the difference. This one is equal to log of 22. This one is the log of 20. Then you have to add 2. So they're going to have 2 different things. So if something's affecting the x, it has to be in parentheses. So see how that's not in parentheses right here? That is not affecting the x. It's affecting the function. So that's the difference between those 2. So x minus 4 in parentheses, move to the right. Plus 7 in parentheses, move to the left. No parentheses, up, down. All right, that's the big difference, okay? And then let's kind of remind ourselves about the reflections. If you have a negative in front of your function, it's reflecting over the x. Same thing, if it's reflecting over the y, the negative will be with the x. And it does have to be in parentheses, okay? A vertical stretch, you're multiplying by a number bigger than 1. And a vertical shrink, multiplying by a number between 0 and 1. All right, let's look at our first example right here. So use your highlighter, highlight what has changed. So you started with log of x, and now all of a sudden you have log of x minus 4 in parentheses plus 2. Okay, so the difference here, we've got a minus 4 in the parentheses, and then we have a plus 2 outside parentheses. So the minus 4 in the parentheses, we're subtracting from the x. That means right 4. And then this one means that you're going to go up 2. Now, I need you to understand that you cannot depend on Desmos for this. You need to be able to look at a function and to be able to do it without Desmos, because these easily can fit in that first part of that benchmark where you have access to no calculator. And we've done it so often that you should start to feel pretty comfortable with the basic ones, okay? So please don't think I have access to Desmos, it's going to work for me, okay? So just got to practice it without using the calculators. All right, this one's a little bit more challenging. We haven't had one like this so far on this lesson. I see 2 changes. This negative is going to be a different change from the 2. You've got to separate the negative from the number because the negative specifically reflects. So this is a reflection. Where is the negative though? Is the negative in the front of the function or is it with the x? It's in front. So if it's in front, it's going to reflect over the x-axis. Now, the second thing that I see is that 2. And that 2 has nothing to do with the reflection, okay? The 2 is going to stretch it vertically. So vertical stretch And I know it's a stretch because it's greater than 1. So if you're multiplying the function by something greater than 1, it's going to make your y values bigger, which pulls it away or stretches it away from the x-axis. And you're going to put factor of 2. So anytime you have a vertical stretch or shrink, make sure that you do the factor of whatever it is. Okay, so now what I want you to do is I want you to pause the video and I want you to work these 3 examples out and then unpause when you're ready to check. Okay, so let's check our work here. I have a plus 2 here. It is not with the x because it's not in parentheses. That means it's going to go up 2. This one, I only have a negative in the front, so that is going to be a reflection over your x-axis. And the last one, I've got 2 things going on. I've got a negative in the front, so it's the same kind of reflection over the x-axis, and then I have a vertical stretch of 3. If that was like 1/3, it would just be a vertical shrink instead. Okay, so this time we have to go a step further. We're going to create our own according to the directions. So it tells me to reflect the f function on the x-axis. So that means when I write the g, so it says graph g, everything should stay the same. Like I don't need to convert anything except to show a reflection. So if it's reflecting in the x-axis, I just kind of stick a little negative right there in the front, right? So I just multiply the entire function by a negative. Now the second part is we're going to translate it right. And right means that I'm going to affect just the x, not the entire function. So I'm going to have to put that up with the x and the exponent. So 4 units to the right would be minus 4. Final answer. So this one's got an asterisk on it because it's a little bit more difficult. We have talked about it in class. No, it is not honors level. You should be able to do this, okay? So I'm going to write down the function. I'm just going to use g this time because I've got to change it. But I'm not changing anything just yet, okay? So this is with no changes. How do I do 2 units up? I just add to the function, right? So I'm going to add 2 at the very end of that. Do not put it in parentheses because if you do, you're going to move it to the left. Don't do that, okay? Now, this is the part. When you do a vertical stretch, you're supposed to multiply the function, correct? But you got 2 parts. You got the logarithm part and then you got the plus 2 part. Typically, when you do reflections and you do vertical stretches and shrinks, you got to multiply the whole thing, but y'all normally have 1 part. This has 2 parts. So here's what you have to do. You're going to multiply it by a factor of 2, correct? That is not sufficient because if you just stick a 2 in the front, you're only multiplying the logarithm by the 2. The rule states you have to multiply the entire function. So you're going to put 2 and then parentheses around the whole thing. Now that's technically correct, but I'm going to tell you if it's multiple choice, the answer is going to look like this. It's going to have 2 log base 1/3 of x plus 4. That's where the 4 comes from because you have to multiply both parts or all parts of that function by 2. And that's it. Just let me know if you have any questions.